All right, you guys, let's get back into some videos. Okay. This next stuff that we're doing, you guys, it's kind of a very, how do I say this? Kind of a thinking process, right? We're not going to be doing like a lot of necessarily like math or whatever. What we're doing is, okay, so if you look here, if we have the graph of a function, can we graph the derivative? Okay, which would be the same thing as if we had a first derivative, can we graph the second? So graphing to a derivative. So this is using the graph of f, sketch a graph of f prime. Guys, here's what I like to do. Okay, we know that anywhere that the slope is 0, so those are like horizontal tangents, right? Those are equations where the slope is 0. Which means that over here on my actual derivative graph, right, those points are going to show up as zeros. Okay? Now check this out. Over here, that slope, I don't know, looks like maybe like a positive 1. I don't know. And these are all positive slopes. So it looks like I had a slope of 1, and these are like all positive slopes, okay? And then I have a bunch of negative slopes. A bunch of negative slopes, which means it's going to all be negative numbers, which is like under there. But I got to connect these, okay? So a bunch of negative slopes, but eventually getting back to here. Like the most negative slope is probably right there. It's like a -1 or something. I don't know. And then I go back to having a few positive slopes. Okay, now, is it definitely curved that way and everything? I mean, maybe not exactly, but it gives you a kind of an idea of what it may look like, all right? Okay, this is where it gets a lot trickier, because now we're going backwards from f prime to f. This is some tricky stuff, because we're going backwards, all right? And you guys, I do not want you to ever do one of these questions without making a sine, there we go, line graph. Okay, without making a sine line graph. Because otherwise these are just like way, way, way too difficult. All right, so they call it a number line. I call it a sine line graph. Make a number line. Make an f double prime number line using slopes and then combine them. All right, super tricky. Here we go. Okay, I am going to go ahead and make a number line for f prime. Now, when we make these number lines, remember the points we put on here, the critical numbers are numbers where f prime equals 0. This is the graph of f prime, you guys. So where does it equal 0? Well, okay, endpoints, which I'm not going to worry about, and here. Okay, and my endpoints, this is on a closed interval, so I suppose I could make this on a closed interval from like -3.5 to 3.5 or whatever. All right, now remember we would do like test points. So if I would do a test point here and I'd say, okay, well, let's test -2. If I tested it and I plugged it into f prime, I'd get a positive. Let's test +2. If I tested it and plugged it in, I'd get a negative. And so I know that my original graph goes increasing, decreasing. That's what it does, okay? From my sine line graph. Now, I am going to make a sine line graph of the second derivative by looking at the graph of the first derivative, okay? And whenever you guys do second derivative, when you're doing it like this, I want you to think the second derivative is simply the slope of the first derivative. That's what it is. So the numbers on my sine line graph, all right, are going to be where the second derivative equals 0. And what's another way to say second derivative? It means the slope of the first derivative equals 0. So can we look over here and see where the slope is 0? How about right there and right there, right? That has a 0 slope at -2, and it has a 0 slope at +2. And then we're going to do test points, all right? Now, for my test points, it's like, okay, what kind of slope is, I'll plug in like -3. -3? Guys, it's a positive slope. What kind of slope is it at 0? That's a negative slope, right? And then what kind of slope is it? That's a positive slope. And what that means is that my original function goes concave up, concave down, concave up. Okay? Oh, I guess it wanted me to make sine line graphs over here. That's right. Okay, so it now says to use the graph of f prime, sketch a graph of f with the starting point of 0, 1. There's my starting point. Okay, so let's take the information first off of here. And it says that I go from negative 3.5 and I increase. Hold on a sec. Okay, I increase and then I decrease. Okay? I increase and then I decrease. Now I've got to add this like concavity though. And so right about at 2 and negative 2, it's got some inflection points. All right, I'll go ahead and put them right there. And then I have to kind of follow the increasing, decreasing, but looking at the sine line graph. And you guys, when I'm doing this part, you do not look at that. Once you make your sine line graph, don't look at that. It's just going to screw you up, okay? All right, so check it out. I'm going to go concave up. Oh, except for that whole part had to be increasing, so that's not quite right. Hold on. Let's do this again. Increasing, concave up. So it's going to go concave up, concave down all the way through there, concave up. Okay? There we go. All right. All right, so for this next question, we're going to go one forward, one backwards. Forward is easier. Let's do forward. Okay, forward's easier. Okay, remember when we go forward, we're just looking at slopes. Okay, we're just looking at slopes. Now, all the way through here, it actually has a very consistent slope, right? And the slope of this line, it goes like up 1 over 1. So the slope is positive 1 all the way up until there. So the slope is positive 1 all the way up until there. That's my slope. Okay? And then, let's see. That line has a slope of 0, and then it gets bigger and bigger and goes to like 1, and then bigger and bigger and bigger until it goes to like a bigger slope. And so it'll kind of go like that, I think, until the slopes start getting very, very big. All right? So this line, though, had a positive 1 slope, so now it turns into a straight line with a positive 1 slope. And then that, the slopes just get bigger and bigger. Okay, to go backwards, much harder. All right. Anytime you're going backwards, you guys, I'm going to insist that you make sine line graphs. Okay? So first thing is, all right, where does f prime equal 0? The only spot I see where that equals 0 is at negative 2. And if I'm doing test points, okay, if I test a number less than negative 2, I get a negative. If I test any number bigger than 2, I get a positive. All right? So what that tells me is that my original graph is going to go decreasing, increasing. Okay? Now, second derivative. Okay, so I got to go like this. This is tricky, guys. F double prime is slope of f prime. And where does the slope of f prime equal 0? I would say like maybe right there. It's actually kind of an undefined point, huh? Because it's like a horizontal asymptote, but the slope is still, anyway, at 0. It almost changes from like, yeah, to that side. It's like a sharp corner, Anyways, and the slopes before that, anything I test before that, these all have positive slopes. And anything I test after that, they all have positive slopes as well. And so it's just like concave up and up. Something like kind of weird's happening in the middle though. All right. So I suppose a possible graph would be, okay, there's like a min at negative 2, and it's going to go down and then up. But it's always going to be concave up. So it's going to be like concave up and then more concave up. Okay? Maybe the fact that there's like a jump right here, there's like that's a slope of, let me think, there could possibly be like a break in the graph or something, maybe. Okay, we don't really know that much information, but that's how I'd be going backwards. All right. Okay, so hopefully that kind of makes sense. Let's go ahead and go through. I actually want to go through, because we're not going to have enough time to do this in class. I want to go through some of these questions from yesterday, specifically, basically 18 through the end. All right. Okay, match the graph of the top row. These are all F with the appropriate ones in the bottom row. Okay, if you guys want, so what I would like you to do is pause the video right now real quick and just see if you can match these up by finding the slopes of these and then turning them into those. Okay, so take a second, just practice, see what you can get. All right, so let's see how you guys did. Anywhere that's going to be a 0. So 0, there's going to be a 0. So that could be this one or this one. Okay. Let's see. Negative means the negative slopes means it's below the axis. Positive slopes means it's above the axis. So below to above. So 18 is definitely going to match up with B. Okay. Okay. Let's take a look at 19. 19. There's a horizontal asymptote right there at 0. But see how the slopes are all positive and then the slopes are all positive. So something that hits 0 but it's positive, positive. Those are all positive, those are all positive. So 19 and C are going to match up. This is a pretty easy one because look, it's a straight line. In fact, I think it's just the line y equals x. And what would the derivative of that be? 1. Right? So 20 is A. Because they're constantly positive slopes, but they're not actually, there's no curving of it, so it's a single number slope. And then this, let's see, let me show you how I would do this one. Okay, so look guys, boom, boom, those are your zeros. So that's going to come down and be a 0 and a 0. And then I have positive slopes, which translates to above the axis, negative slopes below the axis, positive slopes above the axis, right? So 21 is going to match up with D. Okay? All right, cool. Let's practice this. Find or estimate the slope of the graph at each letter point. So at A and B, these are actually going to have the same slope. Let's see, I'm going to go down to over 3. So that one has a slope of like negative 2 over 3. So does this one. Negative 2 over 3. This one has a slope of 0. That's pretty easy. This one has an undefined slope. Okay, now we're going to get a little bit trickier. Okay, this has a slope of 0. This slope right here, it's almost like, okay, so what you could do if you're trying to estimate, it's like, go ahead and like draw a tangent line or something. You know, and you can go like as far as you want, maybe to there or something. Be like, okay, it goes like up 4 over 4 or something. Right, and you just kind of like estimate it. Well, anyways, all I know is it's a positive slope. To me, it does kind of look like it's positive 1, I think. That's a positive 1 slope. That's like a negative 1 slope. Okay. Okay, let's estimate them here. That's pretty steep. This I would go with more, oh gosh, maybe like a positive 3. I'm just kind of guessing with that. That looks like it's pretty close to 0. That I'd probably go with like negative 1. So we're just like estimating our slopes there. All right. Okay, let's look at these we'll do these last 2 questions. These are just review questions. We're going to do these as a part of the homework, and I'll still be able to keep it under 20 minutes. See if I want to do any of these. Nah, we'll do those later. Okay. So for number 23, point moves along the curve so that the y-coordinate dy dt is increasing at a rate of 2 units per second. At what rate is the x-coordinate increasing when x is 8? Here we go. Take the derivative of this with respect to t. This is like 1/3, right? So it becomes 1/3 x to the negative 2/3 dx dt. Okay? dy dt is 2. I'm going to go ahead and move this down to the bottom. And then dx dt is what I'm looking for. Okay? Well, to get dx dt by itself, I'm going to multiply this up. So 3x to the 2/3 times 2 is dx dt. Oh, I should have put x in a while ago. That's okay. X, it did tell me over here, x was 8. I could have put that in a little bit ago. That's fine now. So I need to figure out what 8 to the 2/3 is. Remember, it means 8 squared cube root. I'm going to do the root first. Okay? So cube root of 8 is 2. 2 squared is 4. So this is going to give me 3 times 4 times 2. So that's going to give me 24. Yeah. 24, and then it's units per second. Okay. So there's that one. The answer more up here. Okay. And then let's look at number 24. All right, F inverse, this is a very good review question, prime of 5 if f of x equals all that. Okay, on the interval, I don't know if that really matters. Well, it just makes it so possible it has an inverse. Okay, F inverse prime of 5 is going to be 1 over f prime of something. And I've got this like magic point that I got to work with, right? And what this magic point says is, okay, f inverse of 5 equals something, which means f of something equals 5. All right, so this is what I always write down for like a magic point. F of something equals 5. Now, this, normally they would give you a calculator, or this one can actually be done by hand. I'll show you guys. The way I would solve this is I'd subtract the 5 over. So I have x to the 3rd minus 4x squared plus 3x minus 12. Typically these don't factor, but this one actually does. Hooray, by grouping. So it's like x squared, and then I can take out a plus 3. And so by grouping, this factors to x squared plus 3, x minus 4, which equals 0 at x equals 4. Nothing over there because I would get imaginary numbers. Okay, so that's this like secret point right here, right? F of 4 is 5, f prime of 5 is 4. Okay, so I found that special point. Now this is telling me the answer to my question will be 1 over f prime of 4, because that's the point that goes along with the 5. How do I find f prime of 4? Well, I come over to here. I find f prime. And I plug in 4. So 4 squared is 16 times 3 is 48. 8 times 4 is 32. So it gives me 16, 17, 18, 19. Okay, so then my final answer, because it's 1 over, ends up being 1 over 19. Okay? So a couple good review questions, and then a couple good questions on figuring out how to find derivatives and stuff from graphs. All right, hopefully that made sense to you all.